Alfred Wegener. Alfred Wegener was a visionary scientist whose revolutionary idea of continental drift profoundly altered the course of geological thought. Born on November 1, 1880, in Berlin, Germany, he was the youngest of 5 children in a devout and intellectual household. His father, Richard Wegener, was a classical languages teacher and pastor, which provided young Alfred with a nurturing environment that valued education. Wegener began to question the prevailing notion that continents had always remained in their current positions. Despite his compelling evidence, many geologists of the time rejected his ideas because he could not provide a plausible mechanism for how continents could move. The scientific tools and understanding of plate tectonics that would later support his theory were not yet available. He married Elske Penn, the daughter of his mentor, meteorologist Wallerda. In 1930, he joined his 4th expedition to Greenland with the goal of establishing permanent meteorological stations on the ice sheet. This mission was critical to understanding Arctic weather systems and their influence on global climate. In 1913, their union brought intellectual collaboration and personal happiness, and they had several children together. Despite the demands of his research and expeditions, Wegener remained a devoted husband and father, writing to his family often during his time away. His letters reveal a man of deep emotion, intellectual rigor, and relentless curiosity, characteristics that defined both his personal and professional life. Nonetheless, Wegener remained undeterred, continuing to refine and defend his hypothesis with additional data from geology, paleoclimatology, and paleontology. His interdisciplinary approach and insistence on empirical evidence distinguished him from many of his contemporaries, even if his theory was not fully accepted in his lifetime. He was struck by the apparent fit between the coastlines of South America and Africa, which seemed almost like pieces of a jigsaw puzzle. He helped develop the theory of air masses and frontal systems, which became foundational in modern weather forecasting. His research extended to the dynamics of glaciers and ice sheets, and he conducted some of the earliest studies on the climatic history of the Earth. His Arctic expeditions were particularly important, not only for their scientific findings, but also for the resilience and leadership he demonstrated in some of the most extreme environments on the planet. He viewed the polar regions as crucial to understanding the Earth's past, climate, and geography, and he often risked his life in pursuit of knowledge. Upon further investigation, he discovered that there were matching fossil records and rock formations on continents, now separated by vast oceans. These observations led him to propose the revolutionary idea that continents had once been joined together in a which he named Pangaea, and had since drifted apart over geological time. This theory, which he called continental drift, was formally introduced to the scientific community in 1912 and elaborated upon in his seminal book, The Origin of Continents and Oceans, first published in 1915. From an early age, Alfred exhibited a fascination with nature and a keen interest in scientific exploration, which led him to pursue higher education in the fields of physics, meteorology, and astronomy. He studied at several universities, including Heidelberg, Innsbruck, and Berlin, ultimately earning his doctoral degree in astronomy in 1905. Although astronomy was his formal field, he soon found his true calling in meteorology and the geophysical sciences. Wegener's path to scientific prominence began in meteorology, where he quickly gained a reputation for innovative thinking. Along with his brother Kurt, he conducted groundbreaking research in atmospheric science and balloon flight, using kites and balloons to measure conditions in the upper atmosphere. His adventurous spirit and scientific curiosity drove him to participate in several expeditions, including the Danish Greenland expeditions, where he conducted extensive meteorological and glaciological studies in harsh Arctic conditions. These experiences not only built his expertise in climate and polar research, but also deepened his interest in Earth's physical features, particularly the shape and placement of continents. It was during his extensive reading and analysis of geological and paleontological data. Wegener's theory was bold and challenged the established scientific consensus, which held that land masses were static and explained geological features through land bridges and In addition to his work on continental drift, Wegener made significant contributions to meteorology. Wegener's dedication to science was matched by a personal life that reflected both stability and sacrifice. Tragically, Alfred Wegener's life was cut short in pursuit of scientific inquiry. In 1930, he joined his 4th expedition to Greenland with the goal of establishing permanent meteorological stations on the ice sheet. This mission was critical to understanding Arctic weather systems and their influence on global climate. Conditions during the expedition were particularly harsh, and supplies were scarce. He exemplified the spirit of scientific inquiry, demonstrating that challenging established norms with evidence-based reasoning is essential for progress. His interdisciplinary approach laid the groundwork for future generations of scientists to explore the intersections of geology, climatology, and geophysics. Wegener's life was a testament to perseverance, intellectual courage, and a profound respect for the natural world. His name now stands among the great thinkers who reshaped humanity's perception of Earth, proving that even in the face of widespread doubt, truth grounded in observation and reason can eventually prevail. His story remains a powerful reminder of how visionary ideas, though often resisted at first, can ultimately revolutionize science and leave a lasting imprint on the world. Determined to ensure the survival of his team, Wegener led a grueling relief mission to deliver essential supplies to a remote outpost. Although the mission was partially successful, he collapsed shortly afterward from exhaustion and exposure. His body was later found by a search party, buried in the ice, and was subsequently interred in a snow tomb on the Greenland ice cap. He died on November 1930, at the age of 50, in an environment that symbolized both his passion and the extreme sacrifices he made for the advancement of science. Although his theory of continental drift was met with skepticism during his lifetime, subsequent discoveries in the mid-20th century, such as the mapping of the ocean floor and the understanding of seafloor spreading, provided the mechanism that Wegener had lacked. These findings led to the development of the modern theory of plate tectonics, which became widely accepted and confirmed the essential truth of Wegener's ideas. Today, his work is regarded as one of the most significant contributions to Earth science, and he is celebrated as a pioneering figure whose vision transformed our understanding of the planet's dynamic nature. Alfred Wegener's legacy extends far beyond the theory he proposed. Rachel Carson was a pioneering American marine biologist and writer whose work reshaped public consciousness about the environment and helped launch the global environmental movement. Born on May 27, 1907, in Springdale, Pennsylvania, she grew up in a rural setting where she developed an early fascination with the natural world. Later, she earned a master's degree in zoology from Johns Hopkins University in 1932, a notable achievement for a woman during that period. Despite facing financial hardship and family responsibilities, Carson remained committed to her academic and scientific pursuits. Over time, Carson became increasingly concerned about the growing use of synthetic pesticides, particularly DDT, and the long-term effects these chemicals were having on ecosystems and human health. She began to gather scientific data, personal testimonies, and field reports that painted a troubling picture of environmental degradation caused by chemical pollutants. This research culminated in the publication of her most influential book, Silent Spring. In 1962, her career took off when she joined the U.S. Bureau of Fisheries, where she worked as a writer and editor. She was tasked with translating complex scientific information into accessible content for the general public, a role that sharpened her skills in science communication and laid the foundation for her later literary successes. Encouraged by her mother, she spent countless hours exploring the fields and woods around her home, which sparked a lifelong passion for wildlife and the sciences. Her first book, Under the Sea Wind, published in 1941, showcased her unique ability to combine scientific precision with poetic language. It was followed by the acclaimed The Sea Around Us in 1951, which won the National Book Award and brought her widespread recognition. This book detailed the mysteries of the ocean in a way that captivated both scientists and the general public. A third book, The Edge of the Sea, published in 1955, completed her sea trilogy and further established her reputation as a gifted interpreter of the natural world. Through these works, Carson not only educated people about marine ecosystems, but also fostered a deeper appreciation for the interconnectedness of life. From a young age, Carson exhibited a talent for writing, originally aspiring to become an author before deciding to pursue biology. Her ability to blend scientific understanding with lyrical prose would later become one of her most defining strengths. She pursued her undergraduate education at the Pennsylvania College for Women, now Chatham University, where she majored in biology. Carson's early works focused primarily on marine biology and the wonders of the sea. Her transition from marine biologist to environmental advocate was gradual but powerful. Over time, Carson became increasingly concerned about the growing use of synthetic pesticides, particularly DDT, and the long-term effects these chemicals were having on ecosystems and human health. She began to gather scientific data, personal testimonies, and field reports that painted a troubling picture of environmental degradation caused by chemical pollutants. Carson's arguments were meticulously supported by data and research, yet they were presented in a way that resonated emotionally with readers. The title alone evoked a haunting image of ecological collapse, and the book's impact was immediate and she lived modestly and avoided the spotlight, choosing instead to let her work speak for itself. She never married and had no children of her own, but she adopted and raised her great-nephew Roger after the death of his mother, demonstrating her strong sense of family and responsibility. Carson found peace in nature and spent much of her free time near the ocean, where she drew inspiration for her writing. Carson taught the world that the environment is not something separate from human existence, but an integral part of our survival and well-being. Her ability to awaken public consciousness without resorting to sensationalism or hyperbole is a rare quality that elevates her work to timeless relevance. She combined the analytical mind of a scientist with the soul of a poet, making her message resonate across generations. Rachel Carson's voice continues to echo through classrooms, courtrooms, and conservation efforts, urging humanity to tread more lightly on the earth, to protect the fragile beauty of the natural world for future generations. Her correspondence reveals a woman of great sensitivity and philosophical depth, someone who saw beauty and meaning in even the smallest details of the natural world. It challenged the practices of agricultural and chemical industries, and questioned the blind faith in technological progress without regard for environmental consequences. She chose to keep her illness largely private, fearing it would be used by her detractors to undermine her message. Her death marked the end of a remarkable life, but not the end of her influence. In the years that followed, her work continued to inspire environmental legislation, scientific inquiry, and public advocacy. She has been honored with numerous posthumous awards, including the Presidential Medal of Freedom in 1980. Schools, parks, and institutions across the United States bear her name, and her legacy lives on in the continued efforts to protect the environment and promote sustainable living. Carson's story is one of scientific brilliance, moral conviction, and personal sacrifice, a story that reminds us that individuals, through persistence and clarity of vision, can change the world. Despite the physical pain and emotional strain, she continued her research and writing with extraordinary dedication. She underwent surgery and radiation treatments, but the disease continued to advance. Even as her health declined, Carson remained actively engaged in public discourse, giving interviews, corresponding with scientists, and advocating for environmental awareness. Her determination to complete and promote Silent Spring in the face of terminal illness stands as a testament to her courage and sense of purpose. The backlash from the chemical industry was swift and intense, with attempts to discredit Carson both professionally and personally. Despite the controversy, Carson remained composed and focused, defending her work with calm authority and unwavering commitment to truth. This research culminated in the publication of her most influential book, Silent Spring. Carson's work also inspired a new generation of environmental scientists, activists, and policymakers. Though she was not the first to raise alarms about pollution and ecological imbalance, her voice carried exceptional weight due to her credibility, eloquence, and moral clarity. She helped bridge the gap between scientific knowledge and public understanding, reminding the world that nature is not an inexhaustible resource to be exploited, but a delicate system that must be respected and preserved. In 1962, the book meticulously documented the harmful effects of pesticides on birds, insects, and entire food chains, warning that continued use of such chemicals would lead to a Silent Spring, one devoid of birdsong and natural vitality. Silent Spring was a groundbreaking work that combined rigorous scientific evidence with a compelling narrative. Her testimony before the United States Congress in 1963 helped spark the formation of regulatory frameworks that would eventually lead to the establishment of the Environmental Protection Agency in 1970. In her personal life, Rachel Carson was known for her quiet demeanor, profound intellect, and deep empathy for living things. Carson faced her greatest personal challenge while writing Silent Spring, as she was diagnosed with breast cancer during the early stages of the book's development. Rachel Carson passed away on April 14, 1964, at the age of 56, in Silver Spring, Maryland. Her writings remain a powerful reminder of the consequences of human activity on the planet and the ethical imperative to live in harmony with nature.